this derivative here is the parenthesized portion right there. Okay? It's not a conjugate symbol. All right. If you look closely at this expression and this one, I think there will be a cancellation between them if we expand it out. So it behooves us to expand it out. The cancellation that I'm noticing, and maybe others, is if I take x squared minus 1 cos x times this sine x, it's going to distribute through there, I'll have x squared minus 1 cos x sine x. Over here I have negative x squared minus 1 sine x cos x. Those two are going to cancel, right? What's the acronym? You see that in advance? You like saw that five days ago or something?
I can't understand you.
What? Am I talking too fast?
No, like what you just said.
There's things to cancel.
Well, maybe if you write it down, I'll see it.
Okay. How many? Let me just ask you guys a question. See if you know. How many terms are in this expression here?
2.
What? How many? Let's take a vote.
Terms?
Carrie, what do you think? How many terms in this little guy right here? Sin x plus 1 has how many terms? What do you say? 2. That's the idea. What do you think? What do you say? 2? Sarita, what do you think? How many terms? How many terms does sin x plus 1 have? How many terms does that have? Terms. How many terms? What did you say? What's a term?
I don't know what's in
How many terms? This little expression, sin x plus 1,
2.
how many terms does it have?
X is 1 term.
Okay, Roger, how many terms does it have?
Sine of x is an operation. So
Well, you gotta answer it. How many terms? 5, 10, 100, negative 5?
that's 2.
2? Davis, what do you think? 1. Justin?
1.
1.
1.
1. 2. Snyder? How many terms?
2.
2. Chan?
2. I don't know.
You gotta guess.
1. 1.
2.
Why is it 2?
Sine x.
Actually, let's ask. Why is it 2?
A term is something you add or subtract. A term is an additive thing.
There's like 1 term.
So how many terms are there? 2. I'm adding 2 things together. I'm adding 2 things together. Right? Sin x is a term and 1 is a term in this little parenthesis where there's 2 terms there. How many terms are there here in this whole expression?
4.
2. This is 1 and this is 1, right? In this entire expression here, there's 2 things happening. This thing added to this big thing. Yes, if I look closer, I go inside this one, there's 2 things inside here, I agree. But I'm saying overall, there is 1, 2 terms here. Terms are additive. Since this has 2 terms, and this has 2 terms, and I'm multiplying them together, I will result in having how many terms? 4.
4.
The product of those 2. I'll have 4 terms when I expand this out. I'm multiplying 2 binomials together. A plus B times C plus D. You're gonna have 4 things, right? Of those 4 terms, one of them is going to be x squared minus 1 cos x sine x. One of them is going to be that. I see the exact same thing here, only negative, so they are going to cancel. There'll be 3 more terms left over here, right?
When you distribute sine of x to that very first part.
It goes to this whole thing right here.
Yeah, so
Sine x goes to this, sine x goes to this.
Yeah, so
1 goes to this, 1 goes to this. Give me 4 terms.
So that first portion of it, you distribute sine of x to that x squared minus 1 cosine of x. That's going to be anything you cancel out.
That's right. That's right. So now that we know that, since we know that this with this will cancel with this one, let's just compute the other 3 terms here and write them in the numerator, right? So it should be, let's see here. 1 is going to give us back the exact same expression. So we'll have x squared minus 1 cos x plus 2x sine x. I multiply the sine through. It with this one has already been destroyed by this one. The sine x with this one will give us 2x sine squared. 2x sine squared x. That's our numerator. And the bottom is sine x plus 1 quantity squared. Okay. We'll leave it like that. That's good enough for us.
Does that say 2x? Oh, wait,
Sine
no.
squared. 2x sine squared, the second one. Okay, so we got through that derivative. was a rough one.
That's the answer?
Yep.
How do we know when we get to the answer?
If it gave you, told you to go what's, let's say, as x is approaching pi over 6,
Mhm.
you would put pi over 6
That's right.
there.
Put pi and 6 in there. And that would tell you the slope of
Y.
this thing, yeah, slope of this thing at pi and 6. That's right. That's what you would know.
Wait. How do we know when to stop though? Is that like when you can't do anything else about it?
Yeah, basically. What else are you going to do at this stage? You can distribute, but there's no avail. It doesn't do anything for it to distribute this piece to the cost, right? It doesn't really help so much. So, if there's no advantage to distribution, you don't do it. The only reason I did it here is because there was a cancellation that was going to take place. Otherwise, it would not have distributed at all.
Wait, what cancels from?
The sine x with this term cancels with this term here on the other side. Because it'd be x squared minus 1 cos
Oh.
sine. X squared minus 1 cos sine.
You should have said that
But one-
earlier.
I did 3 times. But one of them is negative.
Not like that.
Okay. I think I used the finger motions and everything. But whatever.
Yeah.
It makes sense now.
Good. So it's not just an aesthetic device there. It's essentially the problem to complete that last step, although it's somewhat gruesome. All right, so now let's do one like Raja is saying, where we actually have to plug in the value and
No.
find the equation of the tangent line in full. That's exciting. Number 50. You should expect derivatives like this in general. Very complicated. Quotients and products of things. Right?
How many rules have you used? You used the quotient rule?
How many rules did we use?
Yeah, we used the quotient rule.
We used almost all of them. I was describing at the very beginning. We used quotient, product, sum, difference, and the trig ones.
Some are different from the ones we did on the board. Derivatives.
Sum and difference you do without even thinking. You know anything about sum and difference? What's the sum and difference rule? X squared plus 5x. What's the derivative? 2x plus 5. I used the sum rule because I could take the derivatives separately and add them together afterwards.
Oh, that's how you got it.
But you do it flawlessly. You don't even think about it. You know what I mean? But I'm just stating that you did use them, at least conceptually. But you don't really think about sum and difference rules so much. They're too basic, perhaps. 50. Y equals 4 sine cos. Y equals 4 sine x cos x. We're supposed to find the equation that, again, I told you the most common problem in these sections, hopefully, is to find the equation of tangent line. That's what you're doing here. Find equation of tangent line at, in this case, it's x equals pi on 3. Like I said, many times they'll give you a special angle so that you can compute it mentally at the end of the problem. Okay, so to find equation of tangent line we described last time, you need to first find the slope of the tangent line, which is our derivative. So that's the first thing. I want to take the derivative. So y prime, I'm changing notation again just to use both notations. So y prime is going to be a product rule. This is 4 sine x times cos x. It's probably the most obvious way to break it up. Okay? So first times derivative second. I'm calling this first. I'm calling this one second in terms of a product rule. Okay? We use a product rule. There's no other way to go. So we have first times derivative of second. What's derivative of cos?
Negative sine x.
All right. So we don't have to write extra notation this time. We can just take the derivatives directly. They're simple enough.